In this video, I'm going to talk about how we can write derivatives in differential form. There is a way we can write derivatives in differential form, and this is how we can do it. Okay. Now, suppose we have this function y is equals to x cubed minus 3 zx. How could we find the derivatives and then write it in a differential form? Okay. As usual, I'll try to write for you the formula or the definition of the differential form at the end of the video. For now, just let us do the example. So derivative, first we will going to find the derivative, let's say d. But before we find the derivative, we could as well write the y in this format, so we can say x cubic minus 3 x raised to power a half. Instead of having it as sad, we can write it as raised to power something. That is better. So let's find now the dy all over dx. Okay, now to differentiate this, to differentiate x cubed is going to be 3x squared, right? And this one is going to be just, let's take the minus 3. We are going to bring this half and then we multiply it with 3, so it's going to be minus 3 over 2. And then here from the power we will subtract 1, just as we studied in the power rule. Okay, so it's going to be 3 over 2 times x raised to power negative a half, because a half minus 1 gives us negative a half. Okay, so we could as well write this in this format, which is 3x squared minus 3x squared minus 3, then here we have 2 or sed x. Okay, so and here we have dy. So instead of writing here down all over dx, we could as well multiply the dx here, and then it becomes like this, like we multiply both sides by dx. So here we no longer have a dx, we will just have all of this and then dx here. Okay, it is just the same thing, we multiplied both sides by dx, so we would have dy in the dy as the subject of the equation. Okay, we'll just leave dy at the other side and then take everything else to the other side. Okay, so this is the differential form. The differential form states that, okay, it states that we could write dy in the form of the derivative of fx, and then we multiply that with dx. It's just a way of writing derivative in such a way that the dx will not be here down. It's going to be here down as it used to be, but it's going to be taken to the other side. Okay, maybe we could take another example as well of writing derivatives in the differential form. Let's say we have this example, which is y is equals to 2x all over 1 plus x squared. As you can see, it's a rational function, and to find its derivative dy all over dx, we absolutely need to use the quotient rule. So the quotient rule states that we will differentiate the top function, and then we're gonna multiply it with the function at the bottom, and then we're gonna subtract that from differentiating the function at the denominator 1 plus x, and then we would multiply that with just the function at the top, 2x, and then we divide all of this by 1 plus x squared, and then we square the function at the denominator. So to differentiate 2x is going to be 2, and then we're going to multiply that with 1 plus x squared, and then we subtract that. If we differentiate this, it's going to be 2x, right? And then we multiply that with the 2x over there. Then we divide everything by the denominator, 1 plus x squared raised to power 2, all of it at the bottom. Okay, now it is going to be much easier. So now what we have is just we're going to expand. So this is going to be 2 plus 2x squared minus 4x squared. Then we divide everything by 1 plus x squared and the whole of things raised to power 2. Okay, this eventually gives us, if we simplify further, it's going to be 2 minus 2x squared all over 1 plus x squared raised to power 2. So at the end of it, what we have is that our dy is going to be equal to 2 minus 2x all over 2 minus 2x squared all over 1 plus x squared raised to power all of this 2, and then we would have all of this times dx, sorry. Okay, so we could again express this, the derivative of this function that we have here at the top, in a differential form, which is like this. So at the end of this video, what I want you to know is that in order to write the derivative in differential form, you get to follow this definition, which is first get the f of that x, the derivative, and then take the dx from here below the dy to the other side. Okay, so I hope you enjoyed the video. If you did, please, if you didn't subscribe to the channel, and press the like button and share with your friends. In case you have any comments, I would like to receive them either here in this in the comments in the YouTube or in the Facebook page. Okay, thank you for watching.